In this video, we're going to talk about determinants, what they are and how to solve them. A determinant is when you take the scalar value function of any square matrix. A square matrix is a matrix that can be defined as an array of columns and shit, let me start that over. What is it? Columns and rows. Oh God. All right. Whew. All right, let me try that again. In this video, we're going to talk about determinants, what they are and how to solve them. A determinant is a scalar value for function for any square matrix. A square matrix is any array of columns and rows that can be arranged such like this. Right here would be a row A and B, and a column would be something like this, A and C. So to solve a determinant matrix is to take the diagonal product of each term. So in this case, I'm going to do A times D minus B times C. That's it. That's for a 2x2 matrix determinant, which is fairly straightforward. For a 3x3 matrix determinant, we have to employ an additional method or an additional step because there's one more term. The way this goes is you take the first top element and then you multiply this top element by the determinant of this matrix here, this smaller 2x2 matrix. So as you can see, I have A here times now the determinant of these two, of these, the square matrix for these two columns. For the next one, it ends up being B, and this can actually be plus or minus depending on how you arrange the square matrix, but for the sake of following along, we'll do minus. So you do minus B and then the determinant of this column and this column, and that's how you make that that square matrix to do the determinant. So it ends up being minus B times the determinant of the matrix DFGI. And then lastly, the last element, you can guess you're going to take this C value, add it and multiply it by these columns for the determinant. So I have C times the determinant of the matrix DEGH. From there, it's just a matter of doing these determinants on smaller levels and then evaluating. So reminding ourselves, 2x2 determinant is just by taking the cross values and subtracting them, multiplying the cross values and subtracting them. So I have A times D minus B times C. Therefore, down here, I would have A times E times A parentheses E times I minus F times H. And that's what we have here. Similarly, I'd have B parentheses D times I minus F times G, like we do here. And once more, we would have plus C parentheses D times H minus E times G, which I have here. Once it's there, it's a matter of distributing and simplifying. Because we kept it all general, it ends up being this big general thing. However, in most cases, when you have numbers, numbers end up being, they could either cancel or add to each other. So most of the time, this simplifies to a much cleaner looking answer because, again, this is a scalar value, and a scalar value is any typical number, not a matrix or a vector or anything like that.